Hello, I'm Mike Sansom and welcome to Explosive Science. This week, Jörg and I have been playing with one of my favourite elements, gallium. And here it is. It's this blue silvery metal that has some amazing characteristics. This stuff can actually melt in your hand. If your hands are warm enough, of course. The melting point of gallium is just over 29 degrees, and that's why my gallium is always kept in the fridge. Otherwise, it turns like this, all liquidy, like some kind of really toxic mercury. And you can pour it in your hand. There we go. And then pour it from hand to hand. So at 29 degrees, this turns liquid. And my body temperature is just over 36. So, yeah, warm enough to melt it all. The other really horrible characteristic of gallium is if you then rub your hands, yeah, filthy. So when I pour a bit of it onto a can, like this, way, that's not a little bit. There we go. Oh, now I've got it in, oh no. Now I've got it in the can. The whole thing's gonna melt. I'll pour a little bit more on. Whee, gone and done it again. Because aluminium has this oxide layer which protects it, it's actually a really reactive metal. So I need to scrape away the oxide layer and that will let the gallium eat into the aluminium can. Then I'll leave it. It's been about 30 minutes since I put the gallium onto this can and you can really see the difference in the can. So to show what this does, I'm going to pull that and it just comes off. That's really weird. Really weird. And you can see all this can, it just peels away. It almost feels like paper now. Very strange. Very strange. Even that bit. There's not a single sharp bit on this can. Very weird. Look at that. You can see the gallium actually got behind the can and caused it to corrode. Amazing. Strange stuff, but on to how we made the slingshot ammo. First of all, we had to make a mold. Usually when I'm casting gallium, I use silicon molds, but as we're making something quickly and we haven't got time for the silicon to set, I use sand casting. This is a really fine sand that I usually use for jewelry making. It's called Delft clay. Basically, it's a fine sand that's mixed with other oils to hold it all together. First of all, you fill up one side of the casting ring with the sand and press it down all the way till it's nice and smooth. Then you push what you want to mold into it halfway. Once that's pushed in about halfway, then got to dust it over with something like bentonite clay so it doesn't stick to the other section. You then place the second ring on top and then pack down a load of sand on top of that. So then you've got two halves of a casting. Then you can separate the rings. You're left with this perfect shape of what you want to cast. We need somewhere for the air to escape to, so I always poke a few holes in the sand and that gives the air somewhere to escape or to expand into. Now we've got the molten gallium, all we need to do is pour it into the mould and let it set.
Crack it open.
Yep. Let's hope it doesn't all fall out. It's okay.
Looks promising.
Good.
I think we
just press it out.
Break.
Yeah.
I think
Excellent.
it's a very good outcome.
Right.
We just have to clean it, of course. We just have to wash it a little bit.
In cold water.
That was the weirdest pouring that I've ever done. So this is our little 52-gram Gallium slingshot ball. Bang! It shattered.
It did shatter. Unfortunately, the gallium didn't do what we had hoped for, but it was pretty dramatic. I was pretty sure it was going to shatter in some way, and it did. You can see the ball going towards the plate, and it smashes into smithereens, sending gallium flying everywhere. Unfortunately, the gallium didn't melt on impact, so it's not the perfect assassination ammunition, but it is pretty impressive. If you enjoyed that video, hit like and subscribe now. And I'll see you next time on Explosive Science.